In chemistry, the empirical formula of a chemical compound is the simplest positive integer ratio of atoms present in a compound. A simple example of this concept is that the empirical formula of sulfur monoxide, or SO, would simply be SO, as is the empirical formula of disulfur dioxide, S2O2. This means that sulfur monoxide and disulfur dioxide, both compounds of sulfur and oxygen, will have the same empirical formula. An empirical formula makes no mention of the arrangement or number of atoms. It is standard for many ionic compounds, like CaCl2, and for macromolecules, such as CO2. The molecular formula, on the other hand, shows a number of each type of atom in a molecule. Also, the structural formula shows the arrangement of the molecule. It is possible for different types of compounds to have equal empirical formulas. Examples: glucose, ribose, acetic acid, and formaldehyde all have different molecular formulas but the same empirical formula, CH2O. This is the actual molecular formula for formaldehyde, but acetic acid has double the number of atoms, ribose has 5 times the number of atoms, and glucose has 6 times the number of atoms. The chemical compound N-hexane has the structural formula CH3CH2CH2CH2CH2CH3, which shows that it has 6 carbon atoms arranged in a chain, and 14 hydrogen atoms. Hexane's molecular formula is C6H14, and its empirical formula is C3H7, showing a C/H ratio of 3:7. Calculation. Suppose you are given a compound such as methyl acetate, a solvent commonly used in paints, inks, and adhesives. When methyl acetate was chemically analyzed, it was discovered to have 48.64% carbon, 8.16% hydrogen, and 43.20% oxygen. For the purposes of determining empirical formulas, we assume that we have 100 grams of the compound. If this is the case, the percentages will be equal to the mass of each element in grams. Step 1. Change each percentage to an expression of the mass of each element in grams. That is, 48.64% C becomes 48.64 grams C, 8.16% H becomes 8.16 grams H, and 43.20% O becomes 43.20 grams O. Step 2. Convert the amount of each element in grams to its amount in moles. Step 3. Divide each of the found values by the smallest of these values. Step 4. If necessary, multiply these numbers by integers in order to get whole numbers. If an operation is done to one of the numbers, it must be done to all of them. Thus, the empirical formula of methyl acetate is C3H6O2. This formula also happens to be methyl acetate's molecular formula.